I'm not congruent, I'm just similar. Welcome back, friends. We are talking about similar polygons. And if you recall last chapter, we were looking at taking something like barf, and dilating it, aka making it bigger or smaller, and what our new product would be called barf prime. For dilations, we calculate the scale factor just like this. That's our K value. So in this case, from the do now we did on Monday, barf is multiplied by a scale factor of 3 and then gets 3 times larger. The way that we would calculate this if we were just given a graph is that we would take our new shape, in this case it's barf prime, and divide it by the original shape, in this case barf. And by that I mean a side length. If you look at the side length of BA prime, I've got 12 across. And then if I look at BA proper, I've got 4 across. When I divide the two, I get 12. 12 divided by 4. And that equals our scale factor, which was 3 all along. Now, these are kind of hard to see if you're just trying to eyeball it. I couldn't tell you how many times bigger this is, 3, 4, but when we actually do the scaling and we take the new BA prime and divide it by BA, the original, I end up with the scale factor. And of course, for this question, dilations are never congruent. If you have a congruent dilation, you are using a scale factor of 1 and therefore doing nothing. So dilations are always similar. Some quick nomenclature for the chapter. We've got similar figures, 2 figures with the exact same shape but different sizes, and the ratio between them that we just learned to calculate is the scale factor. And again, that is going to be the new divided by the original. And when we are writing our similarity statements, that's what this is, we would say triangle ABC is similar to triangle DEF. And this little sign right here, the top part of a congruent sign, is our similarity symbol. And all this little symbol means is that this triangle or shape is similar to this triangle. The ratios between the side lengths would all be equal. So when you're doing this little new divided by original, you're going to end up with different calculations. And those different calculations will all be equal because they should be the scale factor. Corresponding parts, this is the sides and angles that can be mapped to one another between 2 similar figures. And this is all this is saying is that if triangle ABC is similar to triangle DEF, then that means that triangle A and triangle D are congruent, similar. See how the A and D are both number 1? That means that B and E would be corresponding and that C and F would be corresponding. It also means things like BC, the side length of BC, would be corresponding with the side length of EF, and therefore they would be similar. It really matters what order you write these in because there's a few different ways to get it right, but there is a million ways to get it wrong. The only theorem we have is kind of a throwback to side, 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 angle, angle, that kind of stuff that we were doing for triangle congruence. If you recall, one of them was angle, 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 and it didn't work. But here, because if I have 2 triangles and I think they're similar, what this means is if they are similar, all the angles in both triangles are exactly the same, but their side lengths are different. Therefore, given 2 triangles, if 2 of the angles are congruent, then the third angle will be congruent. This means that in this picture specifically, angle C would be congruent to angle F. And this is because in any triangle we have 180 degrees. And to calculate this third angle, we would just multiply, idiot. 180 minus subtraction 106 and 31. And that would result in getting the brand new mystery angle. In this case, it would be C, but the same calculation would be done for F, meaning that both of these angles are going to be 43. Some very quick practice. A similarity statement is just saying that triangle something is similar to triangle something. And the way we're going to figure this out is, let's say I'm going to start at R, and I'm going to go R, S, T. So that means that my triangle R, S, T. And there's other ones to pick. We could have picked T, S, R, S, R, T. But in this case, I picked R, S, T. Now we're going to do the same motion starting over here, X, Y, Z. See that? R, S, T, X, Y, Z. That's what I'm talking about with corresponding parts. Now, we have our similarity statement. Triangle RST is similar to triangle XYZ. And next up, I'm going to find the scale factor. And I have a very specific, smart way to do this. I'm going to make my little fractions. I know that they're equal because they're all going to equal the scale factor. And now if you recall from a couple slides ago, I'm going to take the new, divide it by the original. In this case, my new is this triangle right here. So I'm going to take that and listen to these words. I am going to put them on top, starting with the smallest, 12, and then I'm going to get bigger as I go. Now, I need to put the original under here, but I need to put the parts that are corresponding. So when I look at 12, that side XY, what part does it correspond to over here? Well, it's the bottom again, RS. So under 12, I'm going to put 20. Under 15, I see that they're corresponding with 25. And then 18 has to be corresponding with the last one, and that's 30. Now, all of these fractions are actually already equal. They're just not reduced to the point where you can see it clearly. Therefore, we need to do that, and just going to say, I learned the smartest method to do this from a student yesterday. This is what she said. If we look here, the difference between 12 and 15 is 3. The difference between 15 and 18 is 3. Down here, the difference between 20 and 25 is 5. And 25 and 30 is 5. This means that our scale factor is going to be 3 over 5. Now, if we did it the old school way that Mr. B learned back in the 40s, we would be saying, oh, I'm going to divide 12 by 2 and 20 by 2, and that would give me 6 divided by 10. And then, oh, I can still reduce it. I'm going to divide 6 and 10 by 2, and that would give me 3 over 5. Boom, we did it. That works. It's great. But I do think that there's an elegance to this, and it kind of takes away the scariness of fractions, in my opinion. This last question is basically the same question as A, because to find the scale factor, we needed to make the corresponding ratios. One last little problem for you. Write a similarity statement. Okay, let's say that this is the new one, and this is the old one. Okay, my similarity statement, I'm going to go triangle DEF. So just to think about it, I went DEF, so now I'm going to go MNP. See how it's the same motion. Is similar to, what did I say? MN, running out of room, P. Write out the scale factor in fractions. Okay, so I'm going to get my stuff ready. And I know they're going to be equal, so I'm going to put my new on top, and I'm going to start with the lowest. We start with the lowest because then we can do that little trick I just showed you with in between these two is this many, in between that many. And I'm going to put the original on the bottom. Let's see. I'm looking. 18 corresponds with 15. I'm going to put 15 here. 24 corresponds with 20. And row, we got an X. This is the whole problem, though, right? So what I'm going to do is I'm going to do the exact same thing. How can we solve for X? Well, I know that these three fractions are all equal. And therefore, if I reduce them, I should be able to figure out what x is. But if I find the scale factor, that can lead me to what x is and give me the scale factor. So I'm going to do my little trick. Between 18 and 24 is 6. Between 24 and 30 is 6. And this is the sign you want. This means that these fractions are going to all be equal and that we did our stuff right. We didn't accidentally think that ED corresponded to NP or something like that. Now, in this case, I've got 15 to 20 is 5. So that means that between 20 and x, there should be 5 numbers, right? Therefore, I'm going to say that x equals 20 plus 5 is 25. It's sort of a trick, but at the same time, it works, and it's easier than the normal method, which would be I'm going to multiply 24 by x, I'm going to multiply 20 by 30, I end up with 24x equals 600, and as we all know, 600 divided by 24 is who cares? I don't want to use a calculator, and with this method, finding the differences between them, putting them in lowest to highest order, I don't have to use a calculator, and it makes more sense. All right, see you in class.